In this video, we're going to begin to learn about exponential functions. So the first thing we're going to do is work with graphing exponential functions. So we've just completed an investigation kind of showing you what the graph of a function looks like when it's exponential. So now we're going to talk about the details behind it. So the title for today's notes are Graphing Exponential Functions. Then make sure you put today's date in the top corner of your paper so you have the notes for today. All right, the parent function of, or the parent equation for exponentials looks like this. Y equals a times b to the x. So we know it's an exponential equation because the x value is in the exponent spot. And we're going to break down what these pieces mean. So a is your initial value. It's where you're starting on the y-axis. It's the y-intercept, essentially. And then b is your base value. That's the number that you're multiplying by each time. So if that number is larger than 1, you have a growth where it's increasing. If that number is greater than 0 but less than 1, you have a decay or decreasing. So the equations you'll see will have x as in the exponent, some number that's being multiplied, and then sometimes it'll be an initial value, but sometimes that number might be 1 and it won't be written. And then just some notation, and it'll start to make sense as we start graphing. If the b value is bigger than 1, the function is an exponential growth. And is increasing, so it just continues to increase. If your b value is in between 0 and 1, so a number that's less than 1 but bigger than 0, the function is an exponential decay and is decreasing. So you'll see two types of exponential graphs. You'll see increasing and you'll see decreasing. So let's take a look at some graphs. All right, so here's our first example. Let's say I gave you the equation y equals 2 to the x. We know it's an exponential equation because the x is in the exponent position. So when we regraph, we'll just use a table like normal. So I'll create an xy table. And I'm going to plug in some values for x and y. So I'm going to plug in -2, -1, 0, 1, and 2. And we're going to see what comes out for those. So using your calculator, you want to hit y equals, clear out what's ever in there, and type in your equation. So we have 2 to the x. Remember, to get the exponent, you have to hit the little caret key, which is underneath the clear button. So if I hit graph, I can get a sense of what the graph will look like. So I'm seeing this is exponential growth because this is increasing. Also, the value for b, remember our equation is the base value. B is bigger than 1, so I can see the growth there. So to get the table, I hit second graph, and now I can kind of figure out these numbers. So when I plug in -2, that's 0.25. -1 is 0.5. 0 is 1. 1 is 2. 2 is 4. And let's put 3 in there as well to get 8. So where these numbers are coming from, let me just show you on your calculator. What your calculator is doing is just taking 2 and raising it to the power of whatever the x value is. So 2 to the second -2 power is 0.25. 2 to the -1 is 0.5. 2 to the 0 is 1. 2 squared, 2 to the first is 2. 2 squared, and then 2 to the third. So that's where those numbers are coming from. So given that, we can now use the graph, and you should have some graph paper ready to go. We can plot the points and draw a good representation of that graph. So I've got -2.25. So I'm just going to put a dot there as close as I can. -1 is a half. 0, 1, 1, 2, 2, 4. And that's where I can start seeing the change. All right, something to notice is that my line here does not go below the x-axis. So I can straighten that out. And the reason for that, and I'll show you on your calculators, when you look at the table, if I just keep going up, notice that these numbers just keep getting closer and closer to 0, but they never actually touch 0. That's because there's something called an asymptote. So this equation has an asymptote, which is a line that the graph is approaching but never actually reaches, because these numbers go on for infinity and they're never going to get you to 0. So when you see these graphs of exponential growth or decay, there's going to be a line where it kind of flattens out, and that's called the asymptote. All right, some last pieces here we can talk about are domain and range, and then we'll look at an example of decay. All right, the domain for this graph, since it's going on forever in both directions, is just -infinity to infinity. And the range, so that's as low as you can go on the graph. So the lowest point I can reach, but I'm never touching, is up to 0. So it goes from 0 to infinity. So domain, remember, is your x values, and range is your y. So we're just looking at the domain and the range for that graph. Okay, let's look at the next example. We're going to look at an example of a decay. So this one we can list as a growth. This is a growth function because it's increasing from left to right. Now we'll look at an example of a decay. All right, our second example will be the equation y equals 1/2 to the x. And we're going to do the same thing where we list the table and graph it. I'm going to look at some negative numbers here. So same idea on your calculators. hit y equals, clear out what's ever in there. This one you're going to need to put in parentheses. So 1/2 to the x. Notice there's a little cursor to the right, so I can shift to get out of the exponent. That way I can keep typing in my numbers. And then hit second, graph. Excuse me, hit graph first so we can get a sense of what it looks like. So this time I'm seeing a decreasing function, which means it's decaying. And then again, the line flattens out over here around the x-axis. It's not going past it, it's flattening out. So we can get our points by hitting second and graph. So when I have -3, I have 8, then 4, 2, 1, and 0.5. So in the table, I can see the y values decreasing as well. It kind of gives you a sense of when you have growth versus decay. So using our graphs, we can plot these points and then identify the key features of this function. So -3, 8. -2, 4. -1, 2. 0, 1. And then 1 and 0.5. So again, we have that kind of J shape, and then it flattens out as it gets closer and closer to 0, but never touches 0. So our domain is going to be the same here. -infinity to infinity. Goes on forever in both directions with the arrows. The range is going to be a little different because this time we're starting from the highest and then going to the lowest. So the highest that we can go is infinity again. And then it goes up till 0. So again, this is going to be 0 to infinity. It's just kind of the reverse of the growth function. And this one you can label as decay, because it's decreasing. And that's graphing exponential growth and decay. We're going to look at one more example where I just change one little number to see how it impacts the graph. But then it should make sense as we look at the problems. And we're going to look at one with growth again. Okay, so we're going to go back to that same equation that we saw earlier, but we're going to add in one extra step here. We're going to say 2 to the x minus 4. So I just added in the little extra piece there. So same idea, we're going to go to our calculators, hit y equals, clear out whatever's in there, and type in. Now be careful, here's the piece, you got to make sure you're not in the exponent, so you got to shift down to the right. See how I shifted there? By hitting the right key, -4. This is what the equation is asking. It's not asking this. So make sure you notice the difference there. Second table. So we'll get our table of values. All right, so we have -1, comma, -3.5, 0, comma, -3, 1, -2, 2, 0, 3, 4. Then plotting those points. We have -1, -3.5, 0, -3, 1, -2, 2, 0, and 3, 4. So this one, the graph just shifted down. The domain is going to be all real numbers again, so -infinity to infinity. The range, though, this time shifted, right? The lowest I can go now is down to -4, which you can see in the equation. And this is a growth function.